Hi, Terry VanNoy. Welcome to Math Class with Terry V. Hope this video helps you out, and if you enjoy it, please share it, comment, or like it. And you can also go to my website, MathPowerLine.com. It's a math resource blog, lesson videos for students, and other resources for parents and teachers. Give me a call or go to my website or email. All right, let's go to today's lesson. So students, let's take a look at what we've got here. This video is the self-quiz as the last video in the series, adding and subtracting rational expressions. So I'm going to assume that you've watched the 4 previous videos, problem sets 1 through 4, and those are just practice. On the first one I spend a little more time going over the concepts, the 4-step process, and for this what we're going to do is have you try 4 problems at a time. Now, if you've seen my other video series, you know that these self-quizzes, I require you to have a piece of paper, and you are going to work these problems by yourself. You're going to hit pause and not just watch me do it, but you try it first. Then I'll go over quickly the steps that are similar to what you've seen in the previous videos. So go ahead and get going. Try these 4 problems on a piece of paper, and then play the video further to see if you're right. There's 8 problems altogether. Now first you want to find a common denominator, and then you want to rewrite each fraction so it's equivalent, and then you're going to add or subtract as indicated, and then simplify, which might mean some factoring. Alright, well first of all, let's take a look at this. Number 1, you have a 2b and you have a 5ab. Alright, what you need to have, obviously you're going to end up with a common denominator of 10 AB. Okay, let me just put it there for a hint. All right, your fraction is going to have a 10 AB in the denominator. For number 2, you have a 4 and an x and a y and another 4. So you're going to end up with a 4xy as your common denominator. All right, on this one you have an r minus 3 binomial and you have a 6. So your common denominator is going to be a product of those two. 6 times r minus 3. Alright, and in this one we have 2 binomials. They are unlike, no way to combine them, so the common denominator is going to be a product of both of those. M minus 1 and m plus 4. We're going to leave them in factored form, and if you want to try the rest, go ahead, hit pause, otherwise I'm going to keep going. Alright, what we need is to rewrite these fractions here with the common denominator. So the original fraction is 5 over 2b. I'm going to extend the line, and if it's 2b, I am short a 5 factor and an a factor. So I'm going to multiply 5a on the top and the bottom there. Okay, the other fraction is going to be 6 over 5ab, and the missing factor I have out of the common denominator of 10ab is a 2. Alright, so multiply top and bottom by 2. Alright, so that means that I have 25a, because I multiply there, and minus 12. At this point, look for a common factor. If you can't see a common factor like a 2 or a 5 or maybe a variable, then you're done. So I'm going to circle that, and that is going to be my final answer for number 1. Alright, number 2. If the common denominator is 4xy, what I want to do is rewrite each of these fractions. So this is the second step, writing equivalent fractions. So copy the original fraction, extend the line a little bit, and we do the same for the second fraction. Now let's figure out what's missing. 4xy is the same denominator that I need, right? So I'm going to multiply by 1s. Basically, I'm done. Here, if it's 4, then I'm missing the xy multiplication there, and I want to multiply top and bottom by xy. Alright, so the 3y is still going to be 3y from the first fraction, and I have subtract, and then this is going to be 6xy squared. All right, now you notice how I can factor out a y from each term. So that looks like it would be a common factor from the top and the bottom. So that would give me 3 minus 6xy. And when I factor out a y on the bottom, that'll leave me with the 4x. Okay, those y's obviously can cancel, leave me with the rest. Okay, I'm going to show the final answers here when we get done. But here in number 3, if the r minus 3 factor is already in the denominator, then I'm going to multiply this r plus 4 by 6. All right, and from the second fraction, I already have an r minus 4 over 6, so I have to multiply by the other factor that I have there. All right, it's going to take some multiplication, and I'm going to finish that in just a moment. So multiplying these out, I get 6r plus 24 plus, and then this trinomial here comes from the FOIL method when I multiply those binomials. All right, so look at my entire list, and I'm going to put them in order here. I have an r squared. That's the highest degree there, highest exponent, so I'm going to take care of that. Notice I have a 6r and a minus 7r, so that'd be a negative 1r, or negative r. And then I have the 24 plus the 12, so that'd be 36. Now there's no way to factor that or simplify it in any way, so if you can see it in all this mess here, there's my final answer. All right, let's go ahead and look at this part here. I'm going to have 6m over m minus 1. The missing factor for my denominator is m plus 4, so multiply top and bottom by m plus 4. Then I'm going to take my second fraction, and I have a 2 on the top and an m plus 4 at the bottom. The missing factor for my common denominator is m minus 1, so multiply top and bottom by m minus 1. All right, now it's pretty crazy here, but I have a distributive property to do this, so it's 6m squared plus 24m and 2m minus 2. All right, we're going to put it all together. I'm going to just write D for now. Now I should not put that for my final answer, but in an intermediate stage I want to write D because I know what the denominator is going to be when I'm done. And to save a little bit of time in writing, I just write D in this stage. But here at the top, I'm going to have 6m squared and 26m minus 2. So here we go. Final answers for those first 4 problems. Now I took a little bit of time to work through those step by step. On the next 4 problems, it's going to be a little bit faster. I'm going to expect you to try it first, and then I'll show you the answer and sort of backtrack on any explanations that are needed. All right, let's go ahead and take a look at 6 through 8. All right, give those a try. All right, here are the final answers. 6 through 8. All right, let's take a look here. Your common denominator is going to be those 2 binomials multiplied. So notice how this x minus 2, the first fraction, means you're going to multiply both top and bottom by x plus 4. And this second fraction has x plus 4 as a denominator. You're going to multiply top and bottom there by x minus 2. By the time you use the distributive property and combine all of your like terms, this is what you have on the top. Now this is written with the squared term at the end. Okay, doesn't really matter, except proper forms usually considered that the higher exponent goes on the left. Number 6, here's your final answer. I hope that you did well. Notice how in n-1 fraction here you multiply the 2 by n-3. In the second fraction you multiply this 5 here by the n-1 factor. Combine your like terms together and you get negative 3n minus 1. Number 7. Again, one binomial times another binomial. You're going to multiply the 5 by the b plus 2, this 5 by the b minus 1. Use distributive property, combine your like terms together, and you should have, hopefully, 10b plus 5 in your numerator. Now when it comes to number 8, this is a very interesting one because this second fraction here, we're going to have to do some simplifying before we even try to add and find a common denominator. Alright, it's always a good tip, and I didn't mention this before, but hopefully you saw it. It's a good tip to reduce and simplify everything before you even start the process, if possible. So I have a v minus 3 binomial on the top, and I'm going to go ahead and pull out a common factor of 3 in the denominator, and that leaves me with v squared minus 9v plus 54, right? Well, as it turns out, that is factorable. So I have my numerator, v minus 3, and I have the 3 factor on the outside, but it turns out that that trinomial there can be factored as v minus 3 and v minus 6, okay? Because I have a middle term of negative 3v and negative 6v, which makes negative 9v. All right. Now, I should have, whoops, made a mistake there. That should be an 18. Okay, if you're confused, sorry about that. 3 times 18 gives you the 54 we started with here. All right, well, obviously, then these binomials can cancel out. So really, what I have here is 1 over 3 times v minus 6. All right, so here's my new problem now. 3v over 3. Let's extend the line because I have to write an equivalent fraction. And I have 1 over 3 times v minus 6. Now, if you look at it, the common denominator is going to be that right there, 3 times v minus 6. So I'm going to need to multiply this first fraction, top and bottom, by the binomial v minus 6. So it's a much simpler problem now. All right, let's multiply this out. That would be 3v squared minus 18v plus 1. Notice how I don't have to multiply anything here in the second fraction. And that's all going to be over my common denominator of 3 times v minus 6. All right, there's my final answer. And it just took some simplification before the process. All right, thanks again for watching this video. And hopefully you've done all the preliminary work before you even get to these self-quizzes. So I hope I didn't go too fast. If you need more help, though, look back at those previous videos, problem sets 1 through 4, how to add or subtract rational expressions. All right, thanks a lot. All right, there you have it. I invite you to go to my website now, MathPowerLine.com, or email me or give me a call. The way I work best with students is live, online in my classroom. So if I can help you in any way, answer some specific questions, the first lesson with me is free as I show you how everything works. All right, study hard and take care.